November 7, 1943, began as an ordinary morning at Recklen Airfield in Germany. Test pilot Hans Werner Lerche circled a freshly captured American fighter, his experienced eyes taking in every detail of the massive aircraft before him. The Republic P-47 Thunderbolt sat on the tarmac like a monument to excess, fully loaded. It weighed over 7,600 kilograms, nearly double the mass of a Messerschmitt Bf 109. Even the engine cowling appeared larger than the complete fuselage of some German fighters. To Lerche, whose career had been built evaluating sleek, weight-optimized German designs, the Thunderbolt appeared absurdly oversized. It seemed to violate every principle of efficient aircraft design that German engineers held sacred. Yet here it was, intact and flyable, Germany's first complete P-47. The story of how this aircraft fell into German hands began 3 days earlier, on November 4, 1943. Second Lieutenant William Roach, a 22-year-old pilot from Pennsylvania, was flying only his third combat mission with the 358th Fighter Squadron, part of the 355th Fighter Group stationed at Steeplemorton, England. That day's operations were complex. While 112B-17 flying fortresses from the 8th Air Force bombed targets at Wilhelmshaven and Gelsenkirchen with an escort of 283 P-47s, Roach's unit had a separate assignment. The 355th was tasked with escorting 9th Air Force B-26 Marauders attacking Luftwaffe airfields at Montdidier and Moulins in occupied France. Tactical strikes independent of the strategic bombing campaign. The 358th Squadron launched 12 P-47s. Roach flew as a spare, a backup position. His role was simple. If any primary aircraft developed mechanical issues, he would take their place. Otherwise, he'd return to base early. 10 minutes after takeoff, Lieutenant John Lanier's engine began showing trouble. Oil pressure fluctuated wildly, and engine temperature climbed beyond acceptable limits. Lanier radioed that he was aborting the mission. Roach immediately moved from spare position into Yellow Flight's number 4 slot. He was now committed to the full mission. The weather over northern France that morning was treacherous. Dense cloud layers stretched from near ground level up to 20,000 feet, with visibility inside the clouds approaching zero. At altitude, temperatures plummeted to minus 15 degrees Celsius, forming ice on wings and canopies. Navigation depended entirely on instruments, dead reckoning, and radio compass bearings. Visual references simply didn't exist, only endless gray clouds. The B-26 bombers attempted to locate their targets, but found conditions impossible. The mission commander made the decision to abort. Bombs were jettisoned over water, and the formation turned for home. The escorting P-47s turned with them. That's when everything went wrong. The return flight encountered severe headwinds that hadn't appeared in the weather forecast. Winds exceeding 100 miles per hour at altitude, blowing directly from England toward France. The P-47s fought against this massive headwind while trying to reach home. Fuel consumption rates skyrocketed. Aircraft that should have had comfortable fuel margins suddenly faced critical shortages. Yellow Flight descended through the clouds for the return journey. In the thick overcast, Roach lost visual contact with his formation. Flying by instruments alone, he maintained what he calculated was the correct heading for England. When he finally broke through the clouds at 8,000 feet, he expected to see the English Channel stretching below. Instead, he saw French farmland. The unexpected winds had blown him dangerously off course. His fuel gauge showed perhaps 40 minutes of flying time remaining, not nearly enough to find England. Below, he spotted an airfield with grass runways and buildings. It appeared to be a British advanced landing ground. With fuel running critically low, Roach made his decision. He would land, refuel, and continue home. He circled once, lowered his landing gear and flaps, and executed a smooth landing. A jeep approached and led him to a parking area. Roach shut down the engine and opened his canopy. That's when he saw Wehrmacht soldiers carrying rifles approaching his aircraft. He had landed at Carpequet Airfield near Cannes, France, a Luftwaffe base. He had flown straight into enemy territory. German soldiers pulled Roach from his cockpit. Within hours, he was en route to a prisoner of war camp. Within a day, he arrived at Stalag Luft I near Barth, Germany, where he would remain until Soviet forces liberated the camp in May 1945. Roach wasn't alone in his misfortune that day. 3 other pilots from the 358th Fighter Squadron were lost during the same mission, all victims of fuel exhaustion caused by those unexpected, severe headwinds. Losing 4 aircraft from a single mission with no enemy contact represented an unusually high loss rate. Captain Walter Kozak, Yellow Flight's leader and the most experienced pilot in the formation, faced the same critical fuel situation. As an instructor pilot with considerable flying time, Kozak attempted to reach the French coast and execute a belly landing on a beach. He came within miles of the coastline before his engine quit. His belly landing in a nearby field was technically perfect. German forces captured him within an hour and sent him to the same prison camp as Roach, Stalag Luft I, where both men would spend the next 18 months. Flight Officer Chester Watson wasn't as fortunate. Flying in a different element of the formation, his fuel situation became critical while still over water. He faced an agonizing choice: attempt to make landfall and risk crashing on the French coast where Germans would capture him, or bail out over the Channel and hope for rescue by British Air-Sea Rescue Services. Watson chose to bail out over the English Channel, approximately 10 miles from the English coast. The water temperature in November measured 9 degrees Celsius. Survival time in water that cold was less than an hour, even with proper equipment. Watson was never found. He was declared killed in action. His body never recovered. Lieutenant Jack Wirtz was the only Yellow Flight pilot besides Roach who made it back to England, but barely. Wirtz flew on fumes for the final 30 miles. His fuel gauges showed empty. The engine was running on whatever fuel remained in the lines. He crossed the English coast and spotted Hastings ahead. There was an airfield there. He called the tower and declared an emergency. There was no time for a normal traffic pattern. He came straight in, gear down, praying the engine wouldn't quit before touchdown. The Pratt & Whitney R-2800 coughed and sputtered on final approach. Wirtz was at 200 feet when the engine died completely. The propeller windmilled uselessly. The P-47 became a 7,000-kilogram glider. Wirtz held the nose up, maintained airspeed, and stretched the glide. He cleared the airfield boundary fence by 3 meters. The Thunderbolt touched down hard on the grass runway, bounced once, and rolled out safely. Ground crews found the fuel tanks completely empty. Not a drop remained. Wirtz had extracted every possible mile from that fuel load. The squadron's mission report that evening listed 4 aircraft lost, 2 pilots captured, 1 killed, 1 aircraft damaged in emergency landing. All losses were attributed to fuel exhaustion from unexpected headwinds. No enemy contact, no combat damage, just weather and navigation errors that transformed a routine mission into disaster. For the Luftwaffe, Roach's capture represented extraordinary luck. They had been fighting P-47s for months, but had never captured one intact and flyable. German pilots had shot down dozens of Thunderbolts, but crashed aircraft were typically too damaged for meaningful evaluation. Burned wreckage revealed little about actual construction methods. This capture was different. The aircraft was perfect, engine undamaged, structure intact, systems complete. Even the fuel tanks and ammunition remained in place, though empty. The captured Thunderbolt, serial number 42 to 22,490, nicknamed Snafu, with squadron code Waifu, remained at Carpaquet for 2 days. Luftwaffe ground crews photographed every detail and documented all markings. They painted over the American stars with German crosses and painted the nose cowl in yellow, the standard Luftwaffe marking for captured aircraft, warning anti-aircraft gunners not to shoot. The Thunderbolt was then flown to Rechlin, Germany's primary aircraft test and evaluation center. Rechlin, officially Erprobungsstelle Rechlin, had been testing German prototypes and captured Allied aircraft since 1926. By 1943, approximately 4,000 personnel worked at the facility, evaluating every aspect of aircraft performance, structure, and systems. The P-47 evaluation began immediately. German engineers had been fighting Thunderbolts over France and Germany for months. The aircraft looked ungainly, flew like trucks at low altitude, and turned like cargo planes. But they kept returning with battle damage that should have been fatal. Pilots who should have been killed by flak or cannon fire returned to base with holes in their wings, fuselages riddled with bullets, damaged engines, yet still flying. And there were always more of them. Every week, American formations grew larger. Every week, more Thunderbolts appeared. German engineers needed to understand why these American aircraft were so difficult to destroy. The answer lay in the details of this captured Thunderbolt. Hauptmann Hans Werner Lerche was Recklin's senior test pilot. By 1943, he had flown over 100 different aircraft types, including multiple captured Allied fighters. He was methodical, experienced, and highly skilled. On his first walk-around of the Thunderbolt, Lerche immediately noticed the size. German fighters were compact. The Bf-109's cockpit was so tight that tall pilots couldn't fly it comfortably. The Thunderbolt's cockpit was enormous. A pilot could stretch, adjust position, even stand halfway up if needed. Lerche started the Pratt & Whitney, our 2800 engine, 18 cylinders in 2 rows air-cooled, displacing 46 liters. The radial engine fired with a deep rumble that shook the entire aircraft. German fighters used inline liquid-cooled engines that ran smooth and refined. This radial sounded crude, almost agricultural, but it ran perfectly. Temperature stable, oil pressure correct, no vibration. Lerche taxied to the runway. The Thunderbolt felt heavy, sluggish. He advanced the throttle and began his takeoff run. The aircraft needed nearly 500 meters of runway. German fighters needed half that distance. Once airborne, Lerche climbed to test altitude. Below 15,000 feet, the Thunderbolt felt exactly as German pilots had reported. Heavy, poor turn rate, mediocre acceleration. Every maneuver required planning. There was no instinctive flying, just brute force physics. But above 20,000 feet, something changed. The turbocharger engaged fully. Power increased dramatically. The engine that seemed crude at low altitude suddenly became efficient and strong. Lerche pushed the throttle forward and felt genuine acceleration. He rolled into a dive. The Thunderbolt dove faster than any fighter he'd flown. The heavy airframe that seemed like a liability became an advantage, building speed quickly and holding it through the dive. He pulled out and climbed vertically. The Thunderbolt maintained energy through the climb. Above 25,000 feet, roll rate was excellent. Controls that felt mushy low down became crisp and responsive. Lerche flew for 40 minutes, testing every maneuver. When he landed, his initial assessment was clear. The Thunderbolt was built differently. Everything about it contradicted German engineering principles. But it worked. And understanding why it worked would reveal something important about American strategy. Over the next several days, German engineers at Rechlin conducted the most thorough evaluation of an American fighter they had ever performed. Every system was examined. Every component was measured. Every design decision was analyzed. The evaluation team included structural engineers, propulsion specialists, armament experts, and aerodynamics analysts. They worked methodically through the aircraft from nose to tail. The first revelation came from examining the structure. German aircraft were masterpieces of weight optimization. Every component was engineered to minimum weight while maintaining adequate strength. Messerschmitt and Focke-Wulf engineers calculated stress loads with extreme precision. They used the thinnest aluminum that could handle expected forces. They spaced structural members as widely as possible while maintaining rigidity. They eliminated every unnecessary gram. The result was light, efficient, fast, and agile aircraft. The Thunderbolt represented the opposite philosophy. The fuselage structure used aluminum sheet metal nearly 2 millimeters thick, where German practice used 1 millimeter or less. Longerons, the main structural members running the length of the fuselage, were built from channel sections 5 millimeters thick. German longerons typically measured 3 millimeters. The former's, circular frames giving the fuselage its shape, were spaced 30 centimeters apart. German practice spaced them 50 to 60 centimeters apart to save weight. German engineers calculated that the Thunderbolt's fuselage was overbuilt by a factor of nearly 2 to 1. The structure could withstand load factors of 15G before failure. Fighter requirements specified 8G capability. The fuselage weighed approximately 1,200 kilograms, more than necessary by German engineering standards. The wing structure showed the same pattern. The main wing spars looked like they belonged on a medium bomber. Each spar was an extruded aluminum I-beam over 10 centimeters tall and 8 centimeters wide with 4 millimeters thick webs. German wing spars were typically half that size. The wing ribs were stamped from thick aluminum sheet and heavily reinforced. German ribs were made as thin and light as possible, just strong enough to hold shape and transfer loads. Engineers ran structural calculations on the wing. They determined the Thunderbolt's wings could handle ultimate loads exceeding 20G before catastrophic failure. No fighter would ever pull 20G. Human pilots would black out or die at 9 or 10G. The wings were designed for loads that could never occur in reality. One German structural engineer wrote in his evaluation notes, "The Americans build bridges when they should build aircraft. This structure is absurdly overbuilt. We could reduce weight by 1,000 kilograms and still have adequate strength for any combat maneuver. This is wasteful engineering." But another engineer recognized the real purpose. He wrote, "The overbuilt structure is not about flight performance. It is about manufacturing and field operations. With this much excess strength, manufacturing tolerances can be much wider. Less skilled workers can build components. If rivets are not perfect, the structure compensates. If welds are slightly defective, the excessive strength means they still hold. Battle damage that would catastrophically fail our lightweight structures is survivable here. The Americans are not designing for maximum performance. They are designing for mass production by unskilled labor and battlefield survival." That insight explained much of what German pilots had reported from combat. Thunderbolts returning to base with battle damage that should have been fatal. Wings with dozens of holes still generating lift. Fuselages riddled with cannon fire still maintaining structural integrity. The overbuilt design meant damage had to be extraordinarily severe before causing catastrophic failure. The empty weight specification showed this clearly. The Thunderbolt weighed 4,490 kilograms empty. For comparison, a Messerschmitt Bf 109G weighed 2,700 kilograms empty. A Focke-Wulf FW 190A weighed 3,200 kilograms empty. The Thunderbolt was 65% heavier than a 109 and 40% heavier than a 190. That weight penalty directly impacted climb rate, turn rate, and acceleration, but it provided massive structural margins that kept pilots alive. The second discovery came from the engine. The Pratt & Whitney R2800 radial engine weighed over 1,000 kilograms by itself. German engineers preferred inline liquid-cooled engines because they were more aerodynamic and efficient. Radial engines were considered old technology. German engineers ran the captured engine on a test stand at full power for extended periods. They deliberately damaged it to test durability. They removed spark plugs from 3 cylinders. The engine kept running with reduced power. They punctured the oil cooler, oil pressure dropped, but the engine continued operating. They shot bullets through 6 cylinders. The engine ran rough but didn't seize. A German inline engine with its liquid cooling system would fail immediately from coolant loss. Radiator damage meant engine failure within minutes. The Thunderbolt's radial engine could lose multiple cylinders, suffer oil system damage, take battle damage that would destroy any German fighter, and still bring the pilot home. It wasn't about performance. It was about survival. The third discovery was the armament philosophy. 8.50 caliber Browning M2 machine guns, 4 in each wing. Total ammunition capacity, 3,400 rounds, 425 rounds per gun. That was nearly 20 seconds of continuous fire. German fighters typically carried enough ammunition for 5 seconds of firing time. American doctrine wasn't about precision, it was about volume. German pilots trained for years learning deflection shooting and gun sight discipline. American pilots received months of training and learned combat tactics in the field. So Americans compensated with ammunition. Miss the first burst? Fire again. Keep shooting until something hits. 8 machine guns were far easier to manufacture than cannons. The ammunition was simpler, cheaper, produced in enormous quantities. The entire system was designed for mass production and minimal training requirements, not engineering excellence. Every system in the Thunderbolt prioritized industrial efficiency over technical perfection. It was heavier, simpler, tougher, easier to build, easier to maintain, easier to fly, easier to repair. It wasn't the best possible fighter. It was the fighter that could be produced by the millions and flown by pilots with minimal training. The Thunderbolt was test-flown multiple times at Rechlin over several weeks. Each flight revealed the same pattern. American engineering focused on production capacity, not aircraft performance. German engineers documented everything. Detailed reports described the structure, systems, performance characteristics, and combat implications. The reports reached senior Luftwaffe leadership. Some officers understood the implications. Others dismissed them. German aircraft were technically superior. German pilots were better trained. Quality would triumph over quantity. But combat results told a different story. After testing at Rechlin was complete, the captured Thunderbolt, now coded T9 plus FK in German markings, was transferred to a special Luftwaffe unit called Circus Rosarius. The official designation was 2. Staffel/Versuchsverband Oberbefehlshaber der Luftwaffe. It was commanded by Hauptmann Theodor Rosarius. Circus Rosarius had one mission: demonstrate captured Allied aircraft to frontline Luftwaffe units. The unit toured German air bases across occupied Europe, showing German pilots what enemy aircraft looked like up close, explaining their characteristics, strengths, and weaknesses. German pilots could examine the aircraft, sit in cockpits, and watch demonstration flights. Rosarius flew the Thunderbolt to bases in Germany, Austria, and France through early 1944. German pilots crowded around the big American fighter, surprised by its size and weight. Rosarius explained what Rechlin had learned. The Thunderbolt was slow to turn below 15,000 feet, attack from below in a climbing turn to get inside its radius. But above 20,000 feet, don't turn with it. Use speed. Diving attacks. Hit-and-run tactics. Never assume battle damage will bring it down. Keep shooting until you see structural failure. Many German pilots looked skeptical. The Thunderbolt seemed so heavy, so awkward. How much threat could it really be? They were experienced. They had been fighting for years. They knew air combat. What could this American machine teach them? Then German pilots started dying at increasing rates. In January 1944, American Thunderbolt production reached industrial scales Germany couldn't match. Republic Aviation's original plant in Farmingdale, Long Island, New York, covered over 1 million square feet of factory space, employing 23,000 workers in 3 shifts. The facility produced approximately 200 P-47s per month, 1 complete aircraft every 3.6 hours around the clock. The Evansville, Indiana plant opened in September 1943, added another 100 aircraft per month from over 1.2 million square feet of factory space, with 18,000 workers. Production would increase to 130 per month by summer. Curtiss-Wright Corporation in Buffalo, New York, manufactured P-47GS under license, adding approximately 50 aircraft monthly. Combined output exceeded 350 Thunderbolts per month, over 11 aircraft per day arriving at ports for England. The production advantage extended to pilots. The United States Army Air Force's training pipeline produced over 2,000 newly qualified fighter pilots monthly from bases across America. New pilots received approximately 300 hours of flight training, including 50 hours in their combat aircraft type. They arrived in England and joined squadrons with experienced leaders who mentored them through first missions. If they survived initial combat, skills improved rapidly through careful instruction. German pilot training had collapsed. Fuel shortages limited flying time. Aircraft shortages meant training on obsolete types. Instructor shortages meant inexperienced teachers. New German pilots arrived at combat units with less than 100 hours total time, sometimes as few as 10 hours in their assigned aircraft. They faced American pilots with 3 times the training and often months of combat experience. German pilot losses exceeded replacement rates. Veterans died. New pilots died on first missions. Squadron strength decreased despite new aircraft from factories. By January 1944, American Thunderbolt pilots had 9 months of combat experience. They had learned what worked. They stopped trying to turn with German fighters at low altitude. Instead, they climbed to 30,000 feet before entering German airspace. When they spotted enemy aircraft below, they dove from above, building speed to over 650 kilometers per hour. They fired bursts from 8 guns, then zoomed back to altitude before German fighters could respond. The 8 machine guns proved brutally effective. American pilots didn't need perfect aim. They pointed generally at the target and held the trigger. With 400 rounds per gun, they could afford to miss. The sheer volume of bullets created a killing zone 30 meters wide and 100 meters long. The .50 caliber Browning fired rounds weighing 43 grams at 890 meters per second. 8 guns firing together produced 34 kilograms of bullets per second. A 3-second burst put over 100 kilograms of metal into the target area. German pilots reported that Thunderbolt attacks felt like flying into walls of metal. Rounds didn't need to hit critical components. Multiple hits anywhere caused cumulative structural damage. Wing skins cracked from repeated impacts. Control surface hinges failed from stress. Engine cowlings shredded, affecting cooling. Fuel tanks leaked from near misses, rupturing seams. Cockpit impacts stunned pilots even when armor stopped penetration. The psychological impact was severe. German pilots, who had dominated air combat for years, suddenly felt vulnerable. The Thunderbolts attacked from above with overwhelming firepower. German pilots couldn't climb fast enough to meet them, couldn't turn tight enough to evade, couldn't damage them enough to bring them down. And there were always more of them. Shoot down 1 Thunderbolt and 2 more appeared. The endless American numbers wore down German morale as effectively as bullets wore down aircraft. Combat loss statistics told the story. In January 1944, 8th Air Force P-47 groups flew over 10,000 sorties. They claimed 114 enemy aircraft destroyed in air combat. They lost 38 Thunderbolts to all causes, including flak, mechanical failure, and combat. The kill ratio was 3-1 in favor of Americans. But more importantly, loss rates per sortie were microscopic. Less than 0.4% of sorties resulted in aircraft lost. German fighter units were losing 2 to 3% of aircraft per mission. The 56th Fighter Group, based at Boxted, England, illustrated American effectiveness. The 56th had been flying P-47s since April 1943. By January 1944, they had 9 months of experience. They knew their aircraft's capabilities intimately. They had developed tactics that worked. In January alone, the 56 destroyed 78 German aircraft confirmed, plus dozens more unconfirmed. They lost 6 Thunderbolts total. The ratio was 13-1. Individual pilots racked up impressive scores. Captain Robert Johnson destroyed 5 German aircraft in January. Major Gerald Johnson destroyed 4. The group's success came from experience, tactics, and aircraft that let them survive mistakes while learning. Other Thunderbolt groups showed similar improvements. The 78th Fighter Group destroyed 62 German aircraft in January, losing 4 Thunderbolts. The 353rd Fighter Group destroyed 48, losing 5. Across all P-47 units, the pattern was consistent. Kill ratios heavily favored Americans, loss rates remained low, and replacement aircraft and pilots arrived faster than losses occurred. American strength grew while German strength declined. Major Gerhard was one of the Luftwaffe's most successful night fighter pilots, with 58 confirmed aerial victories, all against RAF bombers at night. He flew Messerschmitt Bf 110 heavy fighters and Junkers Ju 88 night fighters. Rott was awarded the Knight's Cross with oak leaves and was the 10th most successful night fighter pilot in history. In February 1944, Rott attended a Zircus Rosarius demonstration at his base, where Rosarius showed captured Allied aircraft, including the Thunderbolt. Rott examined the American fighter and was struck by how different it was from anything the Luftwaffe flew. The overbuilt structure, the massive engine, the simple rugged systems, everything designed for production and survival rather than performance and efficiency. Rott understood immediately what this represented. The Luftwaffe was fighting a different kind of war than they had prepared for. German aircraft were masterpieces of engineering, each one carefully designed, precisely built, beautifully balanced, but they were fragile. When hit, they failed catastrophically. And there were never enough of them. American aircraft were crude by comparison, but they were tough. When hit, they absorbed damage and kept flying. And they came in endless numbers. Rott said to his fellow officers after the demonstration, "We can shoot down 10 of these and 20 more arrive the next day. That's the real problem, not the aircraft, but the production system behind them." German pilot losses accelerated through winter and spring 1944. In February, Luftwaffe fighter strength on the Western Front dropped 12% despite new aircraft from factories. March saw losses of 15%. April losses reached 17%. The problem wasn't aircraft production. Germany was building over 900 fighters monthly. The problem was pilots. Experienced pilots died faster than training schools could replace them. A newly trained German pilot with 200 hours of training and no combat experience survived an average of 3 missions before being killed. The Luftwaffe shortened training to increase pilot throughput. That made it worse. Pilots with 100 hours of training died on their first mission. Americans had the opposite problem. They had too many trained pilots. The United States Army Air Forces produced over 2,000 newly qualified fighter pilots monthly from training schools across America. Most had 300 hours of training, including 50 hours in their combat aircraft. They arrived in England, joined operational units, and flew first missions with experienced leaders. American replacement pilots had time to learn. If they survived their first 5 missions, survival probability increased dramatically. The Thunderbolt's ruggedness meant mistakes didn't always equal death. A pilot could be hit, damaged, and still make it home to learn from experience. German pilots in lighter, more fragile aircraft died from the same mistakes. By March 1944, average Luftwaffe pilot experience on the Western Front dropped below 100 total flying hours. Average American Thunderbolt pilot experience exceeded 300 hours. The experience gap meant German pilots lost fights they should have won based on aircraft performance alone. And the Thunderbolts kept coming in numbers Germany couldn't match. Every day, more arrived at English ports. Every week, new pilots joined squadrons. Every month, American strength increased, while German strength decreased. When Germans shot down a Thunderbolt, 2 more replaced it within days. When Germans killed an American pilot, 2 trained replacements arrived within a week. The American system operated like a machine, producing aircraft and pilots faster than Germans could destroy them. German commanders recognized the crisis and tried desperately to adapt. Luftwaffe Tactical Headquarters issued new directives throughout winter and spring 1944. Orders emphasized avoiding high-altitude combat where Thunderbolts excelled. Pilots were instructed to attack only when holding altitude advantage. They were told to use hit-and-run tactics at low altitude where Thunderbolt performance was weakest. They were ordered to disengage immediately if American fighters gained advantageous positions. The tactics made sense on paper. In practice, they failed repeatedly. The fundamental problem was that Thunderbolts didn't fight alone. They operated in formations of 16 to 48 aircraft with excellent radio communication and coordinated tactics. American flight leaders positioned their formations deliberately, usually at high altitude with sun behind them. They controlled the engagement geometry. German pilots, trying to follow their new tactical directives, found themselves forced into disadvantageous positions repeatedly. If German fighters climbed to gain altitude over American formations, the Thunderbolts dove away, building speed Germans couldn't match, then climbed back to altitude farther away. If Germans tried attacking from below at low altitude, they had to climb through the altitude band where Thunderbolts were fastest and most maneuverable. If Germans tried refusing combat entirely, American fighters escorted bombers unopposed to bomb German cities and factories. The Luftwaffe couldn't win by fighting and couldn't afford not to fight. Individual German pilots developed personal tactics that sometimes worked. Some became expert at identifying isolated American stragglers and attacking before the formation could respond. Some mastered the art of diving attacks from directly above, where American pilots had poor visibility. Some learned to fake attacks from one direction, then reverse suddenly, catching Americans in vulnerable turning positions. These tactics occasionally succeeded, but they required exceptional skill, perfect execution, and luck. Most German pilots lacked the experience for such complex maneuvers, and even successful attacks often failed to bring down Thunderbolts due to their structural toughness. The Luftwaffe tried concentrating fighters for mass attacks that might overwhelm American formations through sheer numbers. In theory, if 50 German fighters attacked 30 Thunderbolts simultaneously from multiple directions, some Germans would get through defensive fire and score kills. In practice, coordinating 50 fighters was extraordinarily difficult. Radio communication was poor. Formation leaders had limited control. Weather scattered formations. And when mass attacks did occur, American defensive fire from hundreds of .50 caliber machine guns created lethal zones that German fighters had to fly through. Even if several Thunderbolts were shot down, German losses usually exceeded American losses. The kill ratio favored Americans, even in mass combats. German technical services tried finding weaknesses in captured Thunderbolt wreckage that tactical units could exploit. Engineers examined every crash P-47 they recovered. They measured armor thickness and angles. They mapped vulnerable components. They identified areas where battle damage had caused failures. Reports went to frontline units detailing attack recommendations. Aim for the oil cooler under the engine. Target the control linkages in the tail section. Fire at the wing root where control cables ran. Hit the turbocharger ducting that wrapped around the fuselage. Some pilots followed these recommendations and achieved kills, but most attacks still failed to bring down Thunderbolts, even when hitting supposedly vulnerable areas. The overbuilt structure meant that damage to one system rarely caused catastrophic failure. Oil cooler hits? The radial engine kept running despite oil loss. Control linkages damaged? Redundant systems allowed continued control. Wing root hits? Massive wing spars absorbed damage without structural failure. Turbocharger damage? The Thunderbolt could fly without the turbocharger, just at reduced altitude performance. The captured Thunderbolt at Rechlin and later with Zirkus Rosarius provided German pilots and engineers extensive knowledge of the aircraft's characteristics, construction, and capabilities. That knowledge helped to some degree. German pilots who had examined the aircraft up close and understood its systems were more effective in combat against it. But knowledge alone couldn't overcome the fundamental imbalance. Germans understood what they faced. They just couldn't produce enough fighters or train enough pilots to counter it. Quality knowledge couldn't defeat quantity production. By March 1944, the Luftwaffe was losing the air war over Germany itself. American bomber formations struck deep into German territory with heavy fighter escort. German fighters attacked and sometimes inflicted heavy bomber losses. But escort fighters destroyed German defenders faster than training schools could replace them. Every major air battle reduced German fighter strength. The Luftwaffe was bleeding to death while American strength grew. The captured Thunderbolt transferred to Zirkus Rosarius continued demonstration duties through mid-1944. Rosarius demonstrated it dozens of times at bases across Germany. He emphasized characteristics, warned about capabilities, showed German pilots attack methods. But fewer pilots came to demonstrations, not because they weren't interested, but because there were fewer pilots. Losses exceeded replacement rates. The Luftwaffe was bleeding experienced veterans. Records show the captured Thunderbolt was last seen at Leipzig-Brandes airfield in August 1944. After that, documentation disappears. The aircraft may have been destroyed in combat, damaged beyond repair, or abandoned as German forces retreated. American investigators searched for it after the war, but found no trace. It vanished into the chaos of Germany's collapse. Hans Werner Lerche survived the war. He was captured by Allied forces in May 1945. American intelligence officers interrogated him extensively about captured aircraft evaluations. In 1946, Lerche was recruited as part of Operation Paperclip, the American program bringing German scientists and engineers to the United States. Over 1,600 German technical personnel were relocated to America between 1945 and 1959. Lerche was sent to Wright-Patterson Air Force Base in Ohio, where he worked until 1968 evaluating aircraft and training test pilots. He became an American citizen and spent his career studying aircraft performance. In the 1970s, he wrote a memoir titled Luftwaffe Test Pilot, Flying Captured Allied Aircraft of World War II. In his memoir, Lerche devoted an entire chapter to the P-47. He wrote that flying the Thunderbolt was his introduction to American engineering philosophy. Americans didn't build aircraft to be perfect. They built them to be good enough, then built thousands of them. He had initially thought it was crude engineering. Years later, he understood it was brilliant strategy. William Roach remained at Stalag Luft until Soviet forces liberated the camp in late April 1945. He returned to the United States, left the military, and worked as a commercial pilot. He rarely discussed his capture. When asked, he would say he made a navigation error that gave Germany their first complete Thunderbolt. But by the time they figured out what it meant, America had already built 10,000 more, so it didn't matter much.